Hi, my name's Lucian Wishick. I'm telling you 3 essential tips for writing async stuff correctly. This is the 3rd essential tip. And the important thing here, this tip is using task completion source to turn event-like things into tasks. I'll be telling you where that's appropriate and how we can do it. I'm going to start by telling you a customer story. Let me read out what the customer said. She said, I have a Silverlight page that uses RIA services async to load the data from the page. It fires an onCompleted method when the load is complete. If the user clicks the print button before all of the page data is loaded, then the printed output does not have all of the data. Then the customer asked, can I use await in some way to wait for the onCompleted event? Well, the short answer is yes. We're going to see how to use task completion source to make this work. Actually, what I've discovered is that although these forms over data are really important for so many of you coders out there, they don't make very exciting demos. So I'm going to go with a different user's code. He has some code that kind of had exactly the same problems as that forms over data person. The forms over data code had a beautiful UI. It was very async, it was very responsive, and that's why the person coding it was running into trouble. So I'm going to go with this other guy's code. He also wanted an async responsive thing. Actually, his code was he was trying to write a Windows 8 and a Windows Phone application for young kids to help them learn how to do counting. The idea was there was going to be an apple tree, and what could happen, it was on a touch surface on a Windows 8 tablet or a Windows Phone device, where the kid could drag apples into the basket, and then it would just help them learn numbers. It was going to actually be a bit like the count from Sesame Street. I'm going to show you how it ran in practice. I don't know if you heard that clearly, but all of the apples made a noise as they dropped down, and they had a small animation. And then the kid drags and drops them into the basket. 1 apple. I'm sorry, we don't yet have professional voice acting, so I'm going to stand by. Ha 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 ha. 2 apples. Ha 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 ha. 3 apples, ha 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 ha. 4, 5, 6, 7 apples, ha 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 ha. Congratulations, Apple Scrumper. Would you like to play again? Yes. And then we can start dragging more apples into the basket. Actually, he had one other thing. Let me show you. He wanted to have more levels with a peach tree and a pear tree, and different fruits could be slightly hidden inside it. So let's look. If ever the child returns to the game, it kind of rustles the apples and it plays an animation and a sound effect. It's like Where's Waldo, just so you can see where the apples are hiding. Well, this is what the user's code looked like. He was writing in VB, you can see. Don't worry, I'm not going to ask you to understand it. He didn't either, nor do I. What happened was that he was using lambdas to respond to events. And what we ended up with, actually, was a nightmare of nested lambdas, even lambdas assigned to fields, lambdas within fields. And what had happened was that the code had grown over time. It became impossible to know what the code was doing. It became impossible to debug. It became impossible to add new features. When I came to this user, I said, look, this is bad. Let's start again. Let's start from scratch. Let's start by drawing a state machine diagram to get at the actual architecture of the game. So this is the state diagram. When it starts, it's going to kick off. Remember, it went when the animation played and the sound effect played for the apples to drop onto the tree. And I've done this small little black box in the state machine to show the work that we're doing to kick off. Then eventually the animation will finish, eventually the sound will finish. When both of those events are fired, then we can get on with the main game. We've got 2 little more black dots where we initialize the game state. We kick off some more animations. And then we're in this stable state. If the user presses, we can... I don't know. You know what? This isn't the right way to go about it either, is it? This is actually equally bad. You know what's the worst about trying to approach it with the state machine diagram? It's that those little black dots, the ones that are actually doing the actual work of our program, they've been relegated to tiny little corners inside the diagram. In fact, this isn't an architecture diagram of what the code does. It's merely become a diagram of when it does it. And actually what happened is that user, well, in the first code, he tried to have a local response to events by responding with lambdas to the completed event. I tried to go, and it was too local, and that's where he ran into troubles. I tried to go in the opposite direction. I tried to go into a state machine diagram, but that ended up too global. And the underlying problem that we're facing is events. Dealing with events, with lambdas, with callbacks, is a difficult programming task. Now, don't get me wrong. Events are here with us. Events are here to stay. I reckon that as professional programmers, we're going to be spending probably a third of our time, half of our time, just writing code that deals with events in one way or another. So the challenge is, how are we going to tame events? Let's look at this. I'm going to start with what I believe is the ideal architecture diagram for this user's program. I think it should only have one state in essence. It can respond to the start event by creating the apples and doing the animation. Or let's look at the pressed event. So we're in the state, stable state. How are we going to respond to a pressed event? Well, 1, we're going to let the kids drag the apple until they release it. If it lands in the basket, then 2, we're going to animate the apple flying into the basket and playing a sound. 3, if that was the last apple, we're going to animate the victory screen and play a sound. 4, remember the victory screen. It said, "Congratulations, Apple Scrumper. Do you want to play again or go home?" We're going to, when a button is clicked, then we're going to navigate to wherever we want to. I really want to write this as a sequential step-by-step, 1, 2, 3, 4, because that's, in my mind, in my architecture, how I think about what the program does. Wouldn't it be wonderful if we could write code that reflected this architecture diagram? Well, we can. But before we get to that, let's just stress what are the principles that we've got. Principle: callback-based programming, as with events, is difficult. If the event handlers that we write are largely independent, then we can leave them as events because they're fine. But if it looks like we've started venturing into nested lambda nightmare territory or state machine nightmare territory, then await is sometimes easier, and we're going to want to tame the events. And a brilliant way to tame the events into awaitable tasks is to use task completion source. We'll see how we're going to use task completion source in a moment, but let's just show you my code for on pointer pressed. Remember what happened. When we get the pointer pressed event, then 1, we're going to let the user drag an apple. I wrote a small routine called drag async, which packages up the pointer pressed, the pointer moved, the pointer released events, all of them inside a single awaitable. I did that using task completion source. Anyway, number 1, we await until the drag async is done. Number 2, we kick off the animation and the sound, and we await until both of them have finished. Number 3, we show the victory screen, and we await until that's present. Number 4, we await until the user has clicked the button to play again. What's brilliant about this is that I've written code that really is like my ideal architecture diagram. So when we spot the right places where this await over event technique should be used, use it. And let's see in the next slide how we're going to use it. Well, the user had written their code in Visual Basic, but actually what we're going to do is we're going to package the play async routine into a library that I happen to write in C#. Let's see what happens, how it works. The end goal is that the user writes await storyboard1.play async. I could have written this code in VB or C#. I happen to do it in C#. When the user calls play async, control flow flows into this method. What's it done? This is going to be hairy, but stick with me. First, it creates a task completion source object. This is kind of a factory for creating task objects. A task object is nothing. It has nothing to do with background threads. It's just an object that can be in one of two states, either not yet completed or completed. And there are various different ways it can be completed. Anyway, it starts out in the not yet completed state. I sign up a completed event handler, then I begin my task, the storyboard, and then I return tcs.task. That's the task that my factory generated. I get to the first await of my async method. What happens here? Well, I return control straight back to the caller. I return control to whoever was calling await storyboard.playAsync. So they're going to await until this task is finished. And then, what happens next? 2 seconds later, the storyboard is going to complete. Let's say it took 2 seconds. So it's going to fire its completed event, and that means it's going to fire the lambda that I signed up to be run when it completes. This lambda, what does it do? It does tcs.trySetResult. What that does is for the task object that we created, initially it was in the not yet completed state, but by doing this, it turns it into the completed state. Well, what that means is that when we were awaiting for the task to finish, it's now finished. So we can unhook the lambda that was listening to the completed event, and it can return to its caller. What happens when an async task returning method returns to its caller? Well, it marks that task as completed. So at this point, anyone who is awaiting storyboard.playAsync will resume their code. Now, this code is a bit hairy. A lot of people don't get it the first time they've seen it. So I'm going to show it to you a second time. Let's see what happens. Await button 1 dot when clicked. Exactly the same pattern. Actually, I'm not going to dig into it too much because you can download these slides and study it yourselves. It's got exactly the same code layout. It creates a task completion source, signs up a handler, awaits for the task to be finished, and then finally it unsubscribes the lambda. So it's a very powerful mechanism, a very common one that you'll be writing very often. What we've done is that we've taken event-based code that fires a completed event or a click event, and we've wrapped it up into a task returning awaitable method. This is a really key thing. There are more places that I could go with this talk. There, again, you can download the Channel 9 slides, or you can look at my blog. We can look precisely at how we created drag async. We can look at how we solve dispatch.run async. We can talk about how we handle cancellation. But I just want to leave you with the most important thing. Callback-based programming, as with events, is difficult. If the event handlers are largely independent, then we can leave them as events. But if it looks like we're turning them into a state machine, then await is sometimes easier. And the way we turn these events into awaitable tasks is via task completion source. I want to go back and answer just one question that people say to me. They say, look, have you pulled a bait and switch on me? What you said was that events are difficult, lambdas, callbacks are difficult, but when I look at your code, you've written an event, you've written an event handler, you've written a lambda, you've written a callback. Have you actually helped me? Well, the answer is yes, I have. Because when we wrap up these things into a task returning async method, we have factored down the code into just 7 lines of code that have to deal with lambdas and callbacks. These 7 lines of code can be written once in a library by the expert programmers on our team, but then for the vast remainder of our code, we're going to stick with very simple await-based code that was a lot easier. Most of our code will look like this. It will look like the on pointer pressed, without any of the complicated nested lambdas. And that's the end of this talk. Thank you very much. Goodbye.